Please write your full name.
Alright. How's it going? Recently, GG, wherever. Recovery.
Your CR only fixed the time 10:30. Even at 10:30 also many of you are not able to join. Hello. Where is your CR? All of you please write your register number in the chat box so that I can take it as attendance.
Click on it, and it says waiting for device.
I will consider the attendance up to 10:45. After that, attendance won't be considered.
This one man destroyed Crypt, and now he's on the run from the.
Okay, let us start. Others can join in their own time and wait in the lobby. I won't permit them. Okay, it's already 10:41. 10 minutes late. Okay. Is my screen visible?
Yes, sir.
I hope we are discussing about the cache memory mapping functions, right? When we talk about cache memory, there are two techniques. One is the mapping functions that makes which block of main memory needs to be placed in which block of cache memory. So that is what we call as cache mapping functions. Once a cache is full or the required data is not available in the cache memory, then one of the block needs to be evicted. Right? That means has to be sent back. Right? Eviction, that word many of you might got familiar. So one of the cache block has to be evicted. Right? Which cache block has to be evicted? There are certain algorithms to decide upon that. That we call it as cache replacement algorithms. Right. So when we talk about cache memory, there are two things you need to learn. One is the cache mapping functions. Right. Cache mapping functions decide upon which block of main memory needs to be placed in which block of cache. So in this slide you might have noticed we have identified one block in the main memory that is in the orange color box, right? That has to be placed in the cache memory, right? So where to place it in the cache, right? Whether can we place it in the first cache block or in the fifth cache block or in the ninth cache block, whatever it may be, we have to decide upon. That we call it as cache mapping functions. So there are three cache mapping functions. One is a direct mapped cache, set associative cache, and fully associative cache. Direct mapped cache means each and every main memory block can be placed uniquely in only one cache block. Right? say here the total main memory blocks is equal to 32, right? Total cache memory blocks is equal to 8, right? So we have to select a cache main memory block that needs to be placed in one of the cache blocks. How we decide upon that? That is the direct mapped cache is one of the technique through which we decide upon that, and the formula for that direct mapped cache is the main memory block modulo number of cache memory blocks, right? Suppose say for example in this example 16 is the main memory block which is referenced by the processor. So 16 needs to be converted into its equivalent binary, right? And you have to see once it is converted into its equivalent binary, you have to split that binary address into index and tag. How many bits for index and how many bits for tag? So the number of bits for index is equal to the number of bits in the cache memory block. You see our cache is of 8 blocks. So 8 is equal to 2 power 3. So 3 bits to be used for index. So the lower order 3 bits, what I have selected here, the lower order 3 bits will be used as index bits, and the higher order 2 bits it will be used for tag, right? So the lower order 3 bits 000, right? That is been searched here, and the higher order 2 bits 10, that is here. Once it is valid, yes, right, then we are accessing the data from that cache block. Okay, so any doubt in this example? Think Vignesh and you, Vignesh, might have shared this PPT materials to your email ID because it's very large in volume. Anyhow, I will create a Google Drive link of all the contents in the entire course from Unit 1 to Unit 5, and I will share it to you. Right. This is one of the important question. Cache mapping functions. Explain in detail about the cache mapping functions is available in your CLA 3 question paper. Okay. So you have to write about direct mapped cache, fully associative cache, and set associative cache. Right. So hereby we are completing for direct mapped cache. There is one more example is also that there are 64 blocks and 16 bytes per block. Right. So to what block number does the address 1200 map? So 1200 is the memory address which is being referenced by the processor, and that particular data item has to be placed in the cache memory block. So where it can be placed? Right. So the block address we have to find, that is the memory address referenced by the memory 1200 divided by the total number of bytes in the block, right? So the block address will be 75, right? So 75 is the cache memory block address. And what is the block number, right? Out of the 64 blocks, in which block the 75 is going to be present? So 75 modulo 64, so you will get 11, right? So 1200 is the byte address, right? That 1200 will be placed in one of the block. Block is the collection of memory locations, right? So how many collections? 16 bytes form one block. So we are dividing by 16 and taking the floor value, right? That triangle that denotes that it is the floor value. Suppose if you invert it and put it, that denotes the ceiling value. So 1200 divided by 16, that will give you 75. So 1200 byte has to be placed in the 75th block. Okay. So where can we place the 75th block in the main memory to the cache, right? So 75th block of main memory can be placed in this 11th block of cache memory. I am repeating, 75th block of main memory can be placed in the 11th block of cache memory. That is what we have identified from this example. So 75 modulo 64. 64 means total number of cache memory blocks, right? So 75 modulo 64 is equal to 11. Okay, clear? And its corresponding the memory visualization is given here, right? So there are 4 bits for the offset. Why 4 bits? Any idea? 4 bits for the offset. Offset means to identify one particular byte within the block. So one block is how many bytes? 16. Right. 16 is equal to 2 power 4. Right. You should be very clear with this. Right. So one block can have 16 bytes. To identify a particular byte within a block, to identify a particular byte within the block, we need this offset. So offset is used to identify a particular byte within the block, right? And index, which is used to identify a block in the cache memory, right? So totally how many blocks are here? 64 blocks. 64 is equal to 2 power 6, right? So 4 to 9, 6 bits for index, and the remaining bits 10 to 31 are for tag field. So whenever you are given a memory address of 32 bits 0 to 31, you have to classify it into offset, index and tag. Offset refers to how many bytes per block, right? That is what offset is. Index means how many blocks in your total cache memory. Tag means whether that particular cache block is relevant to the main memory block or not. That is 10 to 30, 22 bits. Okay. Usually all the memory addresses will be of 32 bit size. It's by default, no change. That is indexed from 0 to 31. So as a summary of this direct mapped cache placement strategy, a block can only go into only one place in the cache, right? It is determined by the block's address, right? The index number for the block placement is usually given by lower order bits of the block's address. Lower order bits that you have to determine. How many lower order bits, that you have to decide based on the size of the cache memory, right? This index is equal to block address modulo number of blocks in the cache, right? Okay. And one more example, 32 word addressable memory, right? So for that, how many bits for index, how many bits for tag, the same thing, but it is given in a colorful visualization, right? 32 bits, 32 main memory blocks, right? And each are word addressable. So 32 blocks in main memory and 8 blocks in the cache memory. How can we map it? And the cache replacement strategies, what I told you, cache replacement strategies. One of the very important cache replacement strategies, least recently used technique, LRU. LRU. That means, suppose you say this particular 2 blocks are in the cache memory, right? And this first block in the main memory is mapped to the cache memory block 1, and this block, right? Are you following my pointer? So this block is mapped to block 2 in the cache memory. Now processor wants a data item from the main memory which is available here. So processor can't access the main memory directly. That particular data item has to be brought into the cache, then only